Hi, everyone, and welcome to Tech Tuesday. As we wait for everyone to jump on here, I'll give a brief introduction. I'm Abby Weber, and I'll be your host today. I work on the marketing team here at Stone Mountain Tool, and for today's webinar, we are excited to be featuring a presentation put together by Kenny Monroe, a product manager with Rochling. We work with Rochling as one of our main material suppliers. Kenny isn't available to be here live with us today, but he pre-recorded a video about predicting the lifespan of Durostone wave solder pallets. Matt Tyrell, one of our tooling experts with Blue Ring Stencil and Stone Mountain Tool, is here to help answer any questions you may have after the presentation. Today's webinar will be recorded and will be available to you through a link that you will get in your email tomorrow. There will be time for a Q&A session towards the end. You'll see a Q&A tab at the bottom of your screen, so feel free to throw any questions you have in there. If we don't get to your question today, we will be sure to follow up, or you are always welcome to contact us directly. Now let's jump right in.
Hello, I'm Kenny Monroe, Product Manager for Durostone Solder Pallet Materials. This video presentation explains how the wave soldering process parameters can affect the lifespan of a solder pallet and also demonstrates our Durostone Material Selector tool. Firstly, we will have a look at the factors which will lead to a reduction in the lifespan of a solder pallet. Flux attack is usually the main cause of a pallet coming to the end of life. It is caused by a combination of flux contents, PCB preheat temperature, solder bath temperature, and the production cycles the pallet is running. Another significant factor that can end the life of a solder pallet is warpage, predominantly the PCB masking area. Typically, the root cause of this issue is the design of the pallet and excessive soldering temperatures. Delamination of thin walls is always a major risk. In processes with high temperatures, composite materials can become brittle and break as a result of handling. We'll now take a look at the wave soldering process parameters and how they affect the lifespan of composite solder pallet materials. Certain type of fluxes can have a detrimental effect on solder pallet materials. Fluxes containing halides significantly reduce the lifespan of epoxy glass matte materials like our Durostone CS761. Similarly, fluxes containing halogen activators can also reduce the lifespan of Durostone CS761 given the right process conditions. In both these cases, our epoxy woven glass Durostone WGR781 is the recommended grade. Fluxes that have been classified according to IPC standards as containing halides reduce the lifespan of epoxy glass matte materials to around 500 cycles. Just as is shown here. Fluxes may be classified as having no halide according to the J standard A, but according to J standard 004B, they have halogen activators. They can also be detrimental to the epoxy glass matte materials like Durostone CS761, typically in high volume production where there's a lot of heat and a lot of flux being applied. The bottom side PCB preheat temperature may seem insignificant, but it can contribute to a reduction in the lifespan of a solder pallet. In the lead-free process, the PCB preheat temperature can range between 90 degrees C and 160 degrees C. What we have found is that when the process starts to exceed a temperature of 130 degrees C or more, then this can contribute to the flux attack, to burning of thin walls and warpage of PCB masking. A high solder bath temperature has numerous effects on a solder pallet. Epoxy resins are best suited for dimension stability, but they do have a lower degradation temperature than vinyl ester resins, for example. When the solder bath exceeds 265 degrees C and the PCB preheat 140 degrees C, we have found that this can result in some severe burning of the bottom side resin and thin masking walls. The final parameter of the soldering process that has a bearing on the lifespan of the solder pallet is the conveyor speed. The process conveyor speed is critical to all parameters. A slow conveyor speed of 0.8 meters per minute or less allows more time for the flux being applied to the surface to build up, heat being absorbed at the preheat stage, and heat being absorbed into the pallet during the soldering. With more heat being absorbed during the soldering process, thinner masking areas are going to expand more and result in warpage. Flux is going to remain active for longer due to the build-up and the higher temperatures, keeping it above the activation temperature even when it exits the soldering conveyor. The higher temperatures are going to contribute to burning of the resin on the surface. And all these parameters are going to contribute to a shortened lifespan of the solder pallet. So having covered the process conditions and their effects on a solder pallet, it is now time to look at how to choose the right grade of Durostone for your process. There's a lot to remember in terms of the material's properties and various possibilities in the wave soldering process, so we have developed a tool that makes it very easy to select the right material for your job. The Durostone Solder Pallet Material Selector has been developed in Microsoft Excel, as there are numerous calculations required to provide the correct result. It is a tool that will make the process of selecting the right grade of Durostone very simple, and will predict what will happen to the material over time in the specified process, giving an estimated number of cycles before it comes to end of life. The tool has a straightforward data entry worksheet which references a database of all the major fluxes used in the PCB assembly industry. It is important to enter as much of the requested data as accurately as possible so that the correct material is recommended and the lifespan predictions are meaningful. So we'll go ahead and enter the data in the first worksheet, give it a PCB name, PCB number and date as a reference. And we'll start off with straightforward process. The first section there is the process parameters. Solder bath temperature standard of 265, bottom side preheat 110 degrees C, line speed 1 meter per minute. And then from the drop down menu you can pick a flux. We'll pick up Alpha Metals RF800. It'll tell you the solid content. And then we'll put in a sort of low spray volume of flux, 30 milliliters per minute. 75% whole fill, and just pick a surface finish. Then we move on to the production. We need to add in how many pallets, number of PCBs in a pallet, how many PCBs are produced per hour, the shift duration, days per week, and this will work out the number of cycles per week that the pallet is running. And then we give in the last section the PCB and the solder pallet information. We give the size of the pallet, the size of the PCB, the height of the tallest component, the gap between SMT and plated through hole. And this will work out, do you have thin walls, do you have thin pocket floors, is the material thickness you've chosen thick enough for the bottom side SMT components. So it'll calculate all this for you. You can just pick yes or no for ASD material, and then optical, obviously a grey material. So if we hit the material button, it takes us to the next worksheet, and it's recommending Durostone CS761, our standard material. And just below that we can see that the solder pallet size has sufficient mechanical strength and the right thickness has been chosen for this process. This worksheet will also indicate if there are any process conditions that are of concern. The solder bath temperature is getting up there to 65, and the flux aggressivity is indicating it is an aggressive flux. If we look over to the right of the lifespan guide, the flux aggressivity indicates that the Alpha Metals RF800 is a J standard 004B rating of ROL1. So it does have halogen activators, and under certain conditions this is going to cause a problem. So this is something we'll have to check out in the lifespan guide. So if we now click the lifespan button, we can see the predicted lifespan for this process. The recommended material is Durostone CS761, so we'll just check that that's selected on the drop-down menu. The lifespan prediction in this case is 8,200 cycles, and we can see right away that flux grade, it's indicating that high volumes of this flux can be detrimental to CS761. And it's highlighting yet again that the flux is an ROL1 according to the IPC standards, which is containing halogen activators. And this is how the solder pallet will end up looking like after a few thousand cycles in the RF800 flux, if sufficient flux is applied to the bottom surface and the temperatures are higher than normal. All other parameters look okay, apart from the bottom here, the pocket floor thickness. There's an alert to say that the material thickness is okay if the PCB sits on top of the material, which means that with a 5mm tall component and 8mm thick material, you have to be careful that you don't make the pocket too thin on the bottom side in case it becomes brittle and breaks. If we go back now to the data entry page, we can start changing some of the values to make a bit more extreme to see what effect that will have on the results. So we'll change the solder bath temperature to 275, bottom side preheat to 130, line speed reduce it down to 0.7 meters per minute, change a new flux. Kester 979 is a typical flux in the industry today. Spray a bit more flux on it, 40 milliliters per minute, change an aggressive surface finish, and we'll increase the production quantity, shifts per day, and we'll also change some of the dimensions on the pallet. We'll reduce the SMD height to see what result that has. We'll change the PCB length and PCB width to make it a bit larger and the same size of pallet. So now we see it's recommending Durostone WGR781, and you can see the flux. It's very aggressive now. There's a red flag at the flux. Now we'll go back in and look at the lifespan. It's predicting a lifespan of only 250 cycles, and that is because we're still looking at the lifespan of CS761. So we'll choose the recommended material, Durostone WGR781. And you can see there's a bit of a dramatic change to 20,000 cycles. That is purely based on the flux type and the high solder bath temperatures, because the solder bath will burn the resin in the CS761, and flux will then be able to attack much easier on a woven glass material like WGR781. Although this tool is predicting 20,000 cycles, it doesn't legislate for all the different types of designs. So it is indicating here that you have to be careful about these extreme process conditions, and that warping of the masking and warpage of the pallet can occur because of the conditions in the process. In these extreme temperatures with a slow conveyor speed, solder pallets must be designed with dimension stability in mind. This example shows a large solder pallet with all strength removed across the centre of the pallet. Pockets have been machined down to as little as 1.2 millimeters thick. It was inevitable that this end user encountered solder flooding at the bottom side of the PCB, as the masking was too weak and it warped when it hit the solder bath. We can also see permanent warpage on the solder pallet after just a few cycles. To finish off this presentation, I'll change the data once again to extreme conditions that will demonstrate the functionality of this tool. So we'll put in a solder bath temperature of 285, increase the bottom side PCB pre temperature to 150 degrees C, slow the conveyor speed down even further, and we'll go back to Alpha Metals to pick one of their halide fluxes. It's a WS856. Increase the spray volume to 50 milliliters per minute, and we'll go for 100% hole fill like they do in automotive PCB assembly. We'll produce 110 PCBs per hour, and then we'll also increase the PCB size without increasing the pallet size, just to show the result when you put in these numbers for the PCB and solder pallet design. We'll also have a very small distance between the SMT components and plated through hole on the bottom side. So we go to the material. You can see now the solder bath has a red flag, the flux is a red flag. It's a halide flux, an ORH1, according to the flux aggressivity. And all the other parameters are in the red there, the PCB preheat, the conveyor speed. And the cycle time, it's 13.6 minutes for each cycle of pallet, but it is short. So then we go to the lifespan, and you see red flags everywhere, red text for the solder bath temperature. You see the masking, warpage of the pallet, the red flags. Even for the WGR 781, it's in extreme conditions. So then we change the predicted lifespan material choice to say S761. And then for the flux grade, we get the big red bar, red flag. It's a halide flux, which reduces the lifespan of say S761 to a minimum amount of cycles. You've also got the same conditions as well with the WGR. Warpage or masking is potential because of the extreme temperatures, the slow conveyor speed, and then the thickness of the walls. 0.5 millimeter walls, they're very thin. High temperatures, you're going to get the resin becoming very brittle after a few hundred cycles, and handling damage will break them. One last aspect to look at is the pallet design and pallet care on this bottom right here. The pallet thickness, it's saying, is okay for the pallet size, but the PCB layout in the pallet, it's flagging up that the material per side on the length and the width is only 12.5 or half an inch on either side of the pallet. So there's an alert there. You'll probably need stiffener bars to stop the pallet bending, especially in these extreme conditions. Pallet cleaning, high solid content, high or to medium spray volume, and line speed very slow. So you're going to need to clean the pallet probably on a daily basis. So the lifespan tool gives you a lot more than just predicting the number of cycles. It's giving you information on how to care for the pallet, what is likely to happen in the process, and you can maybe then design around the issues you're going to face with these extreme conditions. So that is the end of this video presentation on our material selector and lifespan guide. I hope you found it informative, and if you do still have any questions, then please do not hesitate to get in touch with me.
Well, hopefully this information was helpful and provided some insight into choosing the correct grade of material. Now let's open up the floor for questions. Yes, this presentation will be sent to you in the email you registered for the presentation with. Where can I get the material selector? Matt, would you like to answer that?
As long as we have the contact information, we can email it out.
Okay, great.
Yeah, it's specific to Durostone. So if that material is not being used, then you know, it's somewhat useless.
Mm-hmm.
I think one key thing to point out is in the ordering process, you know, we don't always have, it's very rare that we have the process parameters. So if our customers can use this material selector tool and put in their process parameters for us, then we can take care of that third stage where we're putting in the fixture size and thickness and whatnot. And from there, we can get a good picture of everything, best material, best thickness, all that stuff. If we only have pieces of the puzzle, again, it doesn't work.
Mm-hmm. Yep, that's good to know. Thank you. Well, if no one else has any questions, we can start wrapping things up here. Thanks. Oh. Yeah, we'll just start wrapping things up. And thanks to Kenny for putting this video together. And thank you, Matt, for joining us today. Thank you, everyone, for your attendance and participation. Just as a reminder, this webinar was recorded, and you can access it through a link you'll receive in your email. As we mentioned before, don't hesitate to reach out to us with any questions, and be on the lookout for future topics. And we look forward to seeing you in September for the next Tech Tuesday. Have a great rest of your day. Thanks, everybody.